Welcome to this explainer. You know, if you've ever looked out at your third, fourth, or fifth grade classroom and wondered how on earth you're supposed to effectively reach the student struggling with basic fractions at the exact same time as the student who is calculating probabilities in their head, well, you are definitely in the right place. Today, we're taking a practical, structured journey through Chapter 4 of Teaching Student-Centered Mathematics to demystify differentiating math instruction in a way that actually empowers both you and your diverse learners. All right, here's our roadmap for today. We've got 1. The differentiation myth. 2. 4 elements of differentiation. 3. The power of parallel tasks. 4. Opening up math questions. And 5. Structuring tiered math lessons. Let's just jump right in.
Section 1. The differentiation myth. Let's kick things off by busting a huge misconception.
There's this anxiety-inducing idea out there that differentiation means creating 30 individual lesson plans and literally kissing your weekends goodbye. It's a trap so many of us fall into. We assume that reaching individual needs means isolating students with their own separate worksheets, but research actually points us to a much more efficient path. Look at this shift. We're moving away from that traditional I, we, you model, where the teacher explains, the class practices, and then you're on your own. If a kid misses step 1 there, they're lost. Instead, we want an upside-down approach. You present a rich, engaging task right at the start, and the math skills emerge dynamically from the students exploring that problem themselves.
And here is the real game changer. When you teach through problem solving, differentiation is already built right in. Because a problem-based task has multiple entry points, a student who needs more support might use physical blocks or repeated addition, while a more advanced student might jump straight to an efficient algorithm. They're tackling the exact same core concept, just at their own developmental level. You don't have to force it. It happens naturally.
Section 2. 4 elements of differentiation. Knowing it happens naturally is great, but we still need a systematic way to plan for it, right?
By just recognizing your students' readiness, their interests, and their learning profiles, you can strategically tweak these 4 core elements. First, you've got content, what they're learning. The big idea stays the same, but you adjust the depth. Second is process, how they actually make sense of that content. Third is product, how they show you what they've learned. Maybe it's a written test, maybe an oral explanation, or a drawing. And finally, the learning environment. The physical setup, the noise levels, and the supportive vibe of the room. I absolutely love how education expert Carol Ann Tomlinson sums up the process element. She calls it taking different roads to the same destination. You are the guide. The mathematical standard is the destination. But whether a kid takes the scenic route using visual organizers or the express highway using abstract symbols, the beautiful thing is they are all arriving at the exact same fundamental understanding.
Okay, Section 3. The power of parallel tasks. Let's open up our educator's toolbox.
When you want the whole class working on the same concept, but you have wildly different readiness levels, parallel tasks are your best friend. Basically, you offer 2 or 3 tasks focused on the same big mathematical idea, but at different difficulty levels. One task might use simple numbers and a really familiar context, while another pushes into larger numbers or something a bit more abstract. Students can choose their task, or you can assign them. But because the underlying math is identical, everyone can meaningfully participate in the whole class discussion afterward.
Now, you might be wondering, how do we actually pull this off in a single computation problem without having to write completely different scenarios every single day? Because let's face it, nobody has time for that.
Well, check this out. By just inserting multiple sets of numbers and giving students a choice, you get instant differentiation. Instead of the standard, rigid, markhead 5 markers and 7 boxes, you offer markhead 2, 5, or 8 markers in 6, 7, or 12 boxes. You just ask them to pick one number from the first bracket and one from the second. A struggling student might grab the 2 and the 6. Someone looking for a challenge, they'll go for the 8 and the 12. It empowers them, it boosts motivation, and it perfectly differentiates the computation without altering the core goal of understanding multiplication.
Moving to Section 4. Opening up math questions. This is all about transforming the materials you already have.
You don't need to toss out your district curriculum to be student-centered. You just need to open it up. Open questions are broad-based. They invite multiple answers or multiple pathways to get there. Because they have a high cognitive demand, they automatically accommodate individual readiness. The ceiling is lifted. Your advanced learners can take the math as far as they want, while others can still find a completely valid, correct entry point to share.
So,
What happens if we take a standard problem and literally just replace a single number with a blank space?
It is wild how much this opens up mathematical thinking. A standard question like 23 times 68 is just a chore. You do the algorithm, get the answer, and move on. But make it an open question, blank 3 times 60 blank. Now you can ask, hey, what numbers could go in those blanks to make a product that's close to 2,000? Suddenly, they aren't just doing rote calculation. They're estimating. They're reasoning about place value. They are actively testing hypotheses.
Here's another awesome technique. Asking kids to compare two situations. Having them write a decimal in expanded form is fine for a basic check, but asking how 34.562 and 43.265 are similar and different, that requires deep connections regarding structure and place value. One kid might say, oh, they use the exact same digits. Another might point out the shifting place value of the 3. It transforms a boring memorization task into rich, dynamic classroom discourse where everyone contributes at their own level.
And our final section, number 5, structuring tiered math lessons.
When a single task just won't stretch far enough, tiered lessons are the way to go, and they are completely manageable if you follow these steps. The key? Always keep the core mathematical destination exactly the same. The source material recommends starting with just 3 tiers, a regular tier for most of the class, an extension tier for an extra challenge, and a scaffolding tier that gives a bit more background support. The golden rule is that all 3 tiers must address the same standard and require real reasoning. We never ever want to give the lower tiers mindless rote practice while the higher tiers get to do all the fun, deep thinking.
Once those tiers are defined, how do you actually vary the challenge? It's simple. You tweak the degree of assistance, or how structured or complex the task is. For instance, if you're tiering by task structure, your scaffolding tier might have specific guided questions about the sides and angles of a shape. Meanwhile, your advanced, open-ended tier might just hand students a bunch of shapes and say, sort these and justify your categories. The core mathematical goal hasn't changed at all, just the complexity and the assistance provided.
So I'll leave you with this provocative thought to chew on before you plan your next math block. How will you turn your next standard math problem upside down? We've clearly seen today that differentiation doesn't mean 30 different worksheets. It means taking the math you already have and using elegant tools like parallel tasks and open questions to let students find their own way to the solution. Start small. Tomorrow, take just one textbook question and put a blank space in it. Just watch what happens to the mathematical discourse in your room. Thanks so much for joining me for this explainer, and happy teaching.